Hi class, this is Dr. Karsten, and today we are going to be working on Lesson 30, and this is from Module 5, Grade 4, EngageNY Math. So in today's lesson, we are going to be adding a mixed number with a fraction. And just as a quick review, a mixed number is a number that is composed of or made up of both a whole number and a fraction. So, for example, if I had the number 2 3/8, that is a mixed number because it has both a whole number, 2, and it also has a fraction, 3/8. So we're going to be adding to numbers such as 2 3/8 a fraction today. So for example, I could have 2 3/8 and add 4/8. So before we really get into our lesson, I just want to remind you that there will be a secret code, and I will be giving that out every little while. Today's secret code is made up of 3 different words, so definitely make sure that you get all 3 to put them in your work. And that, I guess, is the big thing. Oh, the other thing is that this lesson is going to be pretty much by the book, so to speak, with EngageNY. However, the next few lessons, I may be digressing slightly from them, so just know that we may be doing things a little differently. All right, so here we go. So if I wanted to add 2 3/8 plus 4/8, there are a lot of different ways that I can visualize this or do this, and we're going to be doing multiple different ways on each problem. You can pick whichever way you want to do for any of our problems. We spent a lot of time over the past week and a half or so really reviewing adding fractions and decomposing fractions and working with fractions to make sure that we are all solid to move forward with the rest of this module. So definitely, however you are comfortable doing this, that's how I want you to do this. So if I am taking a look at 2 3/8 plus 4/8, what I am going to do for this problem is that I'm going to hold on to that 2, so to speak, and we've talked about this before, and I'm going to add my 2 fractions together. And that's the first way that I'm going to do this. So I'm going to write equals, and then I'm going to hold on to that 2. So I'm going to write 2, and now I'm going to add my 2 fractions. They already have common denominators. Remember that common denominators means that the denominators are the same. Think about what you and I have in common. We're both human beings. That's something that's the same about us. So common denominators, it means that they're the same, they're like. That's another way that you may have heard it. Okay, so we have our 2. Now let's add 3/8 plus 4/8. And when I add 3/8 plus 4/8, since the denominators are the same, I can just add my numerators. 3 plus 4 is 7. And my denominator stays what it is, 8. And again, this is telling us the size of the pieces, or how many pieces make up a whole. So here we have 3 pieces plus 4 pieces is 7 pieces. What size are those pieces? They're eighths. All right, so this is one way that I could have done this problem. I'm going to show you 2 more ways. Again, if you're really comfortable with this way, then that's the way that you're going to do it. And I am going to give you our first secret word, and our first secret word is orange. O-R-A-N-G-E, orange. Okay, so here we go. I'm going to do this now using a number line, and this is really just to help us visualize it. So if I have a number line, now I do not need to start my number line at 0 or even at 1 because I really just need to have the whole number 2 there. So I'm going to go ahead and write the number 2. And you know that to the left we have 1 and we have 0. And then continuing to the right, we're going to go up to 3 and possibly higher. Who knows? Well, we do actually know, I guess, because we did just do this. So I can go ahead and put my 3 here for this problem. And then what I want to do is I want to partition this off into 8 equal-sized pieces as best as I can. Why am I doing 8? Take a look at your denominator. Your denominator is the thing that's going to tell you what you're doing. Since we're working with eighths, we want to turn this into eighths. So I'm going to go ahead and do that. So that's where 2 1/2 would fall. I always like to do my quarters next. And then I do my eighths. And then this would continue on, and I could draw in some more eighths over there. Okay, so again, I'm going to really highlight, I think, my half, make it darker, and then highlight my quarters a little bit too. So now let's mark off where 2 and 3/8 would be. So we start at 2, and then we need 3/8. 1, 2, 3. And this is where 2 and 3/8 is. And now what I want to do is I want to add 4/8 onto that. So I'm going to go and I'm going to hop up 4/8. 1/8, 2/8, 3/8, 4/8. And that, I can show that by doing this and showing that I added 4/8. I should have left a little more room, I apologize. And where do I land? Well, 2 and 1, 2, 3, 4, 5, 6, 7 eighths. And that's exactly what we got before. So here we're modeling this with a number line, and we're showing that we started at 2 and 3/8, we added 4/8, and we landed at 2 and 7/8. Another way that I could do this, and this might help some of you, is to draw tape diagrams. Now for this, I have tape diagrams, and there are a couple different ways that I could do that. I think I'm going to switch colors just because I feel like we need to have something a little different now. So I'm actually going to do separate tape diagrams to make it really, really clear to you. I'm not going to have them connected because I really want you to visualize this. So this would be one hole. Sorry, I'm just torn. I really want to do it the right way. So let's see how this goes. And here's another one. And then here's a third one. And I'm just trying to make sure I don't go off the page. Now I have 3 holes, so I have to show that this is equal to 1. And so then we'd have 1, 2, so this is 2 holes, right? And again, I'm just really showing you another way to visualize this. And then, since we're working with eighths, we need to go ahead and partition this off into eighths. Oh, this one's no good. That one has to go. Let's try this one. A little better. So we have 1, 2, 3, 4, 5, 6, 7, 8. And what I'm going to do is I'm going to shade in 2 and 3/8. Alright, so we have 1 hole, 2 holes, and then we have 1, 2, 3/8. Let me just go ahead and show that this is 3/8. Okay, and then what happened was we added on another 4/8. And I'm going to go ahead, I'm just going to use my highlighter. Again, I'm really just doing this for you to see this. So we started with 1 hole, 2 holes, and 3/8. And now we're going to add on 4/8. So I'm going to add on 1/8, 2/8, 3/8, 4/8. And now what you can see is we still have our 2, but now this part here is 1, 2, 3, 4, 5, 6, 7, 8. And again, I'm really just showing this for you to be able to visualize what happened here, so that we end up with 2 and 7/8. Okay. I don't know if that's helpful to some of you or not. I'm probably not going to be doing this a lot this time, just for the first one to show you. But really what we're going to be sticking with today is we are going to be working with number lines, and we are going to be working with just adding it, going linear like this. All right, so let's try another example. So for this one, we had 2 and 3/8 plus 4/8 is equal to 2 and 7/8. Now, what happens if we end up with a number if our fractions, when they added together, are greater or larger than a whole? Well, let's go ahead and do an example like that. And I just want to make sure I have enough room. So here we go. So let's say that I was adding 2 and 3/8 again, so we'll start with the same thing. But now, let's say that I added to that 5/8. So what would happen with this one? So again, let's go ahead and we can, and this is why we can do this. If I'm looking at 2 3/8, another way that I could write that, and I'm just going to do this on the side, is I could say 2 plus 3/8. And then I'm adding 5/8 to that. So all that I did here was I pulled those apart, right? And now I could say, well, I can add my 3/8 and my 5/8 together. So that's what I'm doing when I'm doing it linearly. So I'm saying, well, I'm going to take that 2 and put it here, because I know that this could be written as 2 plus 3/8 plus 5/8. And now I'm just going to go ahead and add my fractions. I have common denominators, so I can just add my numerators. 3 plus 5 is 8, and it's going to be 8/8. So now what you should all be noticing right away is that 8/8 is equal to 1 whole. So instead of saying 2 and 8/8, saying 2 and a whole, we could say 3. So remember, this is just going to be 2 plus 1 whole. So the answer is going to be 3. Let's show that really quickly on a number line. So we're going to do basically, and again, I didn't leave enough room up top. I apologize. I'm going to start with 2. I'm going to go ahead and have 3 here. And then I'm going to mark in there I'm going to partition all my 8s. Again, I'm using 8s because that's my denominator. So I have a half, I'm putting in all my quarters. Now I'm going to put in my 8s. So there's a half, there's my quarters and my 8s. So again, we are starting at 2 3/8. So 2, 1, 2, 3/8. And now we're adding on 5/8. So we have to hop 1, 2, 3, 4, 5. And again, I'm going to go ahead and throw in a couple more 8s over here. So we hopped 1, 2, 3, 4, 5 8s. Let me model that. Let me use a different color just to make it pop a little. So plus 5/8. So we have what we started with, 2 3/8 plus 5/8. And where did we land? We landed on 3. Because 2 3/8 plus 5/8 gave us 8/8, or 1 whole. So we got all the way up to that next whole number here, right? And so this is our answer. It's actually already there. I don't need to write it. But I'm just going to write here that that would be the same thing as 2 8/8, just so we can see that. Okay, so let's take the same problem and let's take a new problem. I think we're ready to move on. So let's go ahead and let's try, 5 2/4. So let's add 5 2/4 plus 3/4. So let me make this so it's the only thing we're focused on. So we have 5 2/4 plus 3/4. So for this problem, again, the idea is that I really want you to think about pulling this apart and just focusing on those fractions. So again, you could think of this as 5 plus 2/4. And because that's a mixed number, it's a combination of a whole number and a fraction. So again, I could be thinking of that as 5 and 2/4. So if I go ahead and I add 5 and 2/4, and I'm going to go ahead and write it like this, because I think that helps us. And then we can use the associative property to say that we're going to put our fractions together. So I'm going to take my 5, and then let's add 2/4 plus 3/4, and we end up with 5/4. So now we have 5 and 5/4, and I'm going to leave that addition symbol in there, or plus sign. So if we have 5 and 5/4, what are we going to do with that 5/4? Do you guys notice anything? I'm really, really hoping that you guys are noticing that 5/4 is a fraction greater than 1. We know this because our numerator is greater than our denominator. 5 is bigger than 4, which means that we can go ahead and we can take this and convert this into a mixed number itself. So what I'm going to end up with is 4/4, and we did a lot of this last week, so I think you all should be really comfortable doing this, and 1/4. So again, I'm pulling out groups of 4/4, and I end up with 4/4 and 1/4. So what can I do with this? Well, what I end up with is that I have 5 plus 4/4 plus 1/4. Well, we know that 4/4 is just one whole, right? So this is really 1 plus 1/4, and we have our 5 too that I just brought down. So we have 5 plus this 1 plus this 1/4. And that's going to be equal to 6 and a 4. So let's go ahead and model that with a number line really quick. So for this number line, so I'm going to start with my 5. I know that I'm going bigger. I'm going to put 6, and I'm going to put 7 just because I like to have those. I like to have whole numbers bracketing what I'm working on. So now I'm not going to put in eighths because my denominator is 4, so I want to show fourths this time. So I always like to put in the half if I can first. Then I'll put in my fourths, and I'll do the same thing over here. So you'd say I have 1, 2, 3, 4 fourths. And again, 1, 2, 3, 4 fourths. So let's mark where we started, which was at 5 and 2 fourths. I'm going to bring that down. We started at 5 and 2 fourths. So that's going to be 1/4, 2 fourths. So we have 5 and 1/4, 2 fourths. So let me mark that. So we have 5 and 2 fourths. And then what did we do? We hopped up 3 fourths. We moved to the right 3 fourths. We added 3 fourths. So 1, 2, 3. And here you can see what happened. When we got to that 2 fourths, we made a whole. We got to 6. And then we added on another fourth. So remember that we did this. Let me grab another color to show that we added 3 fourths. And we ended up at 6 and a fourth. And you can see that we went to 6 and added a fourth. All right, let's do this. I want to actually show you the same problem in a slightly different way. And again, if you're feeling pretty solid, I'm going to tell you that this is how you're going to do your work. But I want to show you one other mathematical way that we could have done this, which is that we could have started with our 5 and 2 fourths and added on our 3 fourths. And what I could have done is I could have thought about, how can I make a whole? I know that when my denominator is 4, I know that 4 fourths is equal to 1 whole. So what could I have done? Well, I could have gone ahead and turned 3 fourths into 2 fourths and 1/4. 2 plus 1 is 3. And again, if this is totally going to confuse you, don't stress. But I am going to give you guys the second special code word. And the special code word is popsicle. P-O-P-S-I-C-L-E. So the code word is P-O-P-S-I-C-L-E. So you had your first code word already near the beginning. Now you got your second one. Okay, so back to this. So we have 5 and 2 fourths plus 3 fourths. And what I want to do is I want to make a whole. I want to make 4 fourths. So what I did was I went ahead and I split the 3 fourths into 2 fourths and 1/4, because now what I can do is I can go ahead and combine 2 fourths and 2 fourths to make one whole. So really what I'm doing here is I have my 5 plus that 2 fourths plus this 2 fourths plus a fourth, and I want to go ahead and associate those two together because that's just going to be one whole. So I end up with 5 plus 1 plus 1/4. And that's going to be equal to 5 plus 1 is 6 and 1/4. All right, I want to do one more problem with you before we jump into the problem set. So let me give us a little bit of clean page to work on. Let's do 3 and 4/6 plus 5/6. So again, the way that I want you to think about this is I really want you to think about this as being 3 plus 4/6 plus 5/6. And then you're going to go ahead and you're going to group these together. You're going to associate them. We're using the associative property. We're choosing who we're going to have hang out together, associate. So now what I can do is I can say that I have 3 plus 4/6 plus 5/6. So again, our denominators are the same, so let's add the numerators, and we get 9/6. So 4/6 plus 5/6 is 9/6. And again, we have a fraction greater than 1. And in this case, our denominator is 6, so my rule is going to be that 6/6 is equal to 1. And so what I can do is I can go ahead and I can split this into, we're trying to convert it into a mixed number. So I'm going to take out groups of 6/6, and I can get 1 out of there. And then I'm going to have 3 left over here. I had 9 pieces, I put 6 there, I have 3 over there. And again, think of these as being added together, right? And then we still have our 3. So now we have 3 plus, this can just become a 1, plus 3/6. And what do we end up with? We end up with 3 plus 1 is 4 and 3/6. Okay, so let's do this the other way. So I'm going to do that over here, and then we'll do a number line. So let me remind you of this other way that we've been doing this. So let's say that I have my 3 plus, well, let me start off here, sorry. 3 and 4/6 plus 5/6. And remember, my goal again is to make a whole. So the other way that we could have done this is to make a whole. So we have 4/6, and what I want to do is I want to split this into something where I can make a whole. Well, from 4/6 to go up to 6/6, because 6/6 is going to give me my whole, I would need 2/6. And then if I have 5 whole here and I put 2 there, I'm going to have 3 over here. So what you have is you have your 3, you have your 4/6, and then you take your 5/6 and you put 2 over here so that these can be combined or associated to make 6/6, which is one whole. So we have our 3, we have our 3/6, which is what was left after we made a whole, and then what we know is that 3 plus 1 plus 3/6, and we end up with 4 and 3/6. And now let's go ahead and let's draw this on a number line. So I'm going to have to probably slide the paper around a few times, make a little room first here actually. Alright, so here is our number line. I finally left some room above it on the last one that we're demonstrating with. I'm going to start with 3 because that's the number that we're starting with here. And then I'm going to go to 4, and I'm going to go to 5. And then what I want to do is I want to mark in there my 6th, and that's because my denominator is a 6. So there's 3.5, and I'm going to put all my 6th in there. Here's 4.5, and I'm going to put in my 6th. So we started with 3, and let me just remind you what our equation was, or our number sentence. 3 and 4/6 plus 5/6. So let's first mark off where 3 and 4/6 would be. So we have 3 and 1, 2, 3, 4, 6. So let me go ahead and mark that. And then what we did was we added 5/6 on. So let's count up 5/6. 1, 2, 3, 4, 5. And now we're going to show that we increased by 5/6. And when we look at that, we can see that we are at 4 and 1, 2, 3, 6, which is exactly what we got. Now I'm hoping that we are also noticing is that we're actually at 4.5 also. All right, good job. So let's go ahead and let's jump into our problem set. All right, so let's get started with this. So again, we are working in lesson 30, problem set, and you have to make sure that you are definitely paying attention to what problems I'm going to assign you. So here we go. Let's take a look at 1A together. So again, here I have 3 and 1/4 plus 1/4. And the way I want you to think about this is that this is 3 and 1/4, or plus 1/4, plus 1/4. And then you can take and hold on to that whole number. So you're going to get 3. And then 1/4 plus 1/4 is 2/4. Or you can do a number line if you want, whichever way you want. Again, we're flexible here. Okay, so now look what they did. It's just flipped around. So we have our mixed number on the right side. We have our fraction that we're adding to it on the left side. And I can still do the same thing. I can do 3/8 plus 5 plus 2/8. I can pull that apart. And when I do that, I'm going to hold on to that whole number, and I'm going to combine my 3/8 and my 2/8. I could have done the commutative property and moved this over and then had this look like this to associate my 3/8 and my 2/8. And that would have been fine, and that's really what we were doing up here too. We associated the 2/4 together, the 2/4 together. So I would end up, let's go ahead and let's add our 3/8 and our 2/8. 3 plus 2 is 5, and we hold on to that 8. Remember, that's our label, so to speak. Just like adding 2 apples and 3 apples would be 5 apples. Same thing would have happened here. 5 and then 3 plus 2 is 5/8. All right, so let's go ahead and let's take a peek here at number 2 and see what they're doing here. So this is really different. Do not let this confuse you. I am not going to have you do this on your own for when you're working on your own. I just wanted us to take a peek at it so that you were familiar with it in case you do see it at some point. So they're saying that we have 4 7/8 and that we want to add something to that to get up to that next whole number, to that 5/8, or sorry, that 5. So what you have to think about is, again, if I have 7/8, what do I have to add to 7/8 to get to the next whole number? What is the next whole number? And my rule, since my denominator is 8, is that 8/8 is equal to 1. So what you want to do is you want to get to 8/8. And what would I have to add to 4 7/8 to get there? I would have to add 1/8. Because 1/8 plus 7/8 is going to give me that 8/8 that I'm looking for. Again, you could have pulled it apart. 4 plus 7/8 plus something is equal to 5. And that might make it easier for you to see that you needed 1/8. Or you could have even done a number line. And I'm going to do that really quickly. So I would have started with my 4 and had my 5. And then I could have marked in all those 8s. And I would have started at 4 7/8. So 4 and 1, 2, 3, 4, 5, 6, 7. And then you can clearly see that you just need that 1/8 more to get to 5. So you could have just modeled that it would be plus 1/8 to get to 5. So let's go ahead and let's take a look at this one. So here again, they just did it backwards. They're saying 2 1/6, and I want to get to 3. So again, we could think of it on a number line. So we could have 2, we want to get to 3, and then we have to divide this up into 6. So we have 2 1/6. Here's 2, here's 1/6. And let's see how far we would have to go to get 3. We'd have to go 1, 2, 3, 4, 5, 6 more. I'm not going to draw that in right now because I want to leave us room to just really quickly, actually I guess we can decompose it here. So for this one, since 6 is the denominator, I know that 6/6 is equal to 1. So now again, I can just do it here. I could have said that 2 plus 1/6 plus what is going to get me to 3. First of all, I know it's 6 because that's what I'm working with. And then I know that 1 plus 5 would give me that whole number if I put those together. Okay. So again, don't stress. You do not have to do these on your own. So let's take a look here at number 3. And actually, we are not going to take a look at number 3. You're not doing number 3. But I do want to mention to you that when it says the arrow way, basically what you are doing is you are going to model this, model what we've been doing on number lines, when we've done our number lines, like we did here. You're going to model this, but you're not going to have a number line. So it would be 5 2/4 plus 3/4 is 6 1/4. and you would just model it with an arrow showing when you're hopping. But you want to make, you're going to model your making one or making one whole, getting to the next whole number. We're not going to do that. I think it's going to be too confusing. I think you guys are really good at adding and subtracting and working with fractions, converting and decomposing. So we're going to jump right into 3. So in the problem set, in question 4, we're going to take a look here at the first one. It says 4 2/3 plus 2/3. So again, what I want you to do is I want you to think of this as being 4 and 2/3 plus 2/3. And again, you can do this whatever way you are comfortable. You can make a whole by pulling this apart, or you can go ahead and just combine them. I'm going to stick with what I think is the easiest for all of you, which is to keep that 4, and then to go ahead and associate the 2/3 and the 2/3, and you end up with 4 plus 4/3. But we have a fraction greater than 1, because our numerator is greater than our denominator. So I want to go ahead and pull that apart. So I want to make 3/3. I know that because my denominator is 3, so my rule is going to be that 3/3 is equal to 1. So I have 3/3 here and 1/3 here. Because I had 4 pieces, I put 3 here and 1 there. 3 plus 1 is 4. And then I'm going to keep that 4. So now what I end up with is 4 plus, this is 1, plus 1/3. So we have 4 plus 1 is 5, plus 1/3 is 1/3. So 5 1/3. And again, you could have put that on a number line, and let's just model that up here really quick. I know I'm taking up all the space, so we know we're starting at 4, we're going to go to 5, and I'm going to put 6. And then because my denominator is 3, I need to do thirds. So I'm going to go ahead and mark those off. And just make my 5 and my 4 and my 6 stand out. So I started at 4 and 2/3, so 4 and 1, 2/3. And then we added 2/3, 1, 2. And we can model that, and then we ended up with 5 1/3. Now again, one other way that you could have done that, and you know what, I'm going to go ahead and write it on a piece of paper for us. Again, the final way that we've been working today is you could have said 4, and well, let me write it, 4 2/3 plus 2/3. Again, what I could have done was I could have made a whole. I could have said 4 plus 2/3, and what do I have to add to that 2/3 to make a whole? To add 1/3. So if I had 2/3 here and I put 1/3 here to make a whole, I would still have a third left, because 2/3, I'd have 1/3, 1/3, 2/3. If this is confusing you, don't stress over this, seriously. So then I'd have 4 plus 1 plus 1/3. And I'd end up with 5 1/3. But again, you don't have to do it this way. I think that most of you are going to be comfortable doing this way. For today, whatever way works for you. Let's do one more problem. Let's take a look at this problem, and I bet you that while I'm doing this problem, I'm going to give you that third code that you are looking for. You already have 2 of them. So let's take a look at this one. You know what, before I get into it, I'm going to give you that code, but do not leave. Make sure you watch this. That third code is TWIST. T-W-I-S-T, T-W-I-S-T. So for this one, we have 7/10 plus 7 9/10. And you know, honestly, I personally would much rather flip these around. I'm not a big fan of having them in this order. So I would much rather say that I have 7 9/10. And you know what? It's addition. So through the commutative property, I'm allowed to do this. And that works so much better for me. Now, some of you are going to say, oh, 9/10. I can take this and turn it into 1/10 and 6/10. So then I'd move my 1/10 over, and I'd end up with 8/10 plus 6/10. So 8 whole and 6/10. Or for those of you who don't see that, let's go ahead and do it this way. We're going to say 7 9/10 plus 7/10. And what is that going to give us? Well, these two are going to combine. They're going to associate. So I'm going to keep my 7, and then I'm going to have 9 plus 7 is 16/10. And now I'm going to go ahead and pull out groups of 10/10. Why 10/10? 10/10 is going to be equal to 1. My denominator is tenths, so that's my rule. So here I'm going to keep my 7. I'm going to end up with 10/10. And over here I'm going to end up with 6/10. And that's because 10 and 6 is 16/10. And now this becomes 7 plus 10/10 plus 6. 10/10 is just 1. So I'm going to go ahead and write that up here. 7 plus 1 plus 6/10. So all I did was change this into a 1. And 7 plus 1 is 8 and 6/10. So again, there's lots of ways you can do this. Now, if this is going to confuse you, don't watch what I'm about to do, but I'm going to do that thing that we just did before also, where I'm going to go ahead and take 7 and 9/10 plus 7/10. And again, we want to make one whole. And one whole we know is going to be 10/10. So again, since I have 9/10 here, I just need one more 10th to make a whole. So if this 7 puts 1 there, I'm going to have 6/10 here. And let's just go ahead and put all our addition symbols in there and bring down our 7. So again, we would have 7. Now this becomes 10/10, which is one whole, plus 6/10. And we end up with 8 and 6/10 again. And again, you could have done a number line if you wanted to. So whichever way you're comfortable with is the way I want you to do these. Your work is to do these 6 problems. So you're just going to do for B, C, D, F, G, and H. So that's going to be your homework. You have your 3 code words. Make sure that you write them down. And I will see you in our Google Classroom. Have a great day, everyone.